Hey guys, it's Mac here. Today we're going to deploy a Docker image to Amazon ECS. As you guys know, microservices are so common, and the reason is very obvious. If you look at a monolith application and one huge application that contains everything, all the dependencies, every single piece that you change, it's going to break the entire application. You have to wait for different teams, for different people to do their thing so you can deliver a new feature. So basically makes the entire software development process very slow. So we use microservices so you can start building smaller pieces of applications that can work well together and deliver the same feature. But the advantage of this approach is basically to deliver the software features very, very fast, because you can have different teams using different technologies working on different part of the application, and they can independently build, test, deploy, and scale their own piece. So microservices is the way to go. But microservices, they come with a problem. Let's say you build a microservice. Now you want to manage an entire cluster. Your business starts growing. You want to deploy as many nodes as you can. But the problem with that is the management of the entire cluster. How to scale all these nodes. How to make sure all the microservices are running. So you have two options. One technology called Kubernetes that basically helps you manage your cluster, and the other one is Amazon ECS. Amazon ECS is container service, which is a localized basically version of Kubernetes for Amazon. It integrates really, really well with other services in Amazon Web Services. So now let's take a look at Docker technology. So we always had this problem of portability, of software portability, and basically shipping the code to production. So a developer creates the technology or writes the program on the machine, but as soon as you move it to production or move it to a different computer, everything breaks. And he or she says, hey, it works on my computer, come take a look. So here's a common problem between all the software products and projects that you encounter, that you always have dependencies that really tightly couple to your application and to the underlying operating system. So Docker solves this problem. Docker puts everything in one container, operating system, dependencies, and your application. You ship the entire container. If a new programmer joins your team, you give a copy of your image and you tell that person, hey, use this base image for your containers, so there's no problem. Now, in this tutorial, we're going to actually use Spring Boot, and we're going to build a microservice. We're going to imagine we have a fictitious retail business. It's going to be an e-commerce application, and this microservice is just going to return an address of your business locations, right? And we're going to create a Docker image for that Spring Boot application. Once we have the Docker image, we're going to deploy it to Amazon ECR, which is the basically registry or repository for Amazon ECS. And then we're going to have CodePipeline to build new versions. As you commit to a repository, AWS CodeCommit, it's going to build a new image and update your image in ECR. And once you have everything ready in ECR, now it's time to create ECS cluster. We're going to create a ECS cluster, and we're going to deploy our microservices to that cluster. And I'm going to show you how to scale a microservice. I can't wait to start this experience. So without further ado, let's get started.
If you look at this architecture, which is a monolithic architecture on top, we have an e-commerce website. Uses different components like shopping, payment, product, and different things. It's got a bunch of applications on it. It's got a bunch of dependencies and programming languages installed on this server, right? So this is a configured, good to go environment for your production, and it's running without any problem. Imagine you're a developer of this website. You're part of the team. Your application is receiving, let's say, 200,000 orders a day, right? It's a heavy traffic website. You can take it down. It's a very mission critical server. And your manager tells you, hey, can you please add this payment method for this new vendor using Node.js, and you start building this Node.js module. Everything is working on your machine. However, as soon as you deploy, you ship this code to production, everything breaks. So the website goes down, the business is losing customers, your manager is upset. So what happened? What went wrong? This is the nature of monolithic application. This is a nightmare, a very common nightmare for a lot of seasoned application developers, which they're very, very familiar with this. So you have a bunch of hard-coded stuff. You have a lot of dependencies, version 2.1, 2.6. You've upgraded last month. Your coworker, deployed a new version using Python 2.7 and didn't point anything in the documentation, and you deployed the new version using Python version 3. So a lot of common issues around this architecture. Well, portability is the main problem with this architecture, and we use containers like Docker is a famous one that helps us create containers so we can isolate our environment, so we can basically put every single piece in an isolated, closed environment and very well protected, well tested environment, so we can use that consistency to make sure as soon as we ship the code, everything is going to work, because we're going to put code, dependencies, and the OS inside the container. We're going to lock the door, and then we're going to ship it to the production, so we know for sure our code is going to work. So portability is the first issue with this model. The second issue is a scaling issue. Let's imagine you want to scale up your payment module, right? In monolith application, you have it's Black Friday and you have no option but scaling the entire application. Although your for example, shopping module or shipping part, for some reason they're not receiving as much as traffic that your payment module is receiving, right? So scaling is going to be a problem. So you have to scale up and down the entire application, which might be very costly. Security is a big concern in monolithic application. If a hacker attacks to your application and exploits one of these dependencies that you use from a third party, so basically the attacker gains access to the entire system, which is not a good thing. Flexibility is a problem here, right? You are basically connecting everything together to make this puzzle work, and everything is tightly coupled. If you change one IP, it's going to break the entire system. This is a very dangerous model, by the way. So heavy processing, as soon as you start the server, right, even if you want to, let's say, scale the entire thing on a load balance it on the different servers, you still have to run all these processes in order to just process one payment, right? So you have to run the entire ASP.NET and dependencies Node.js in order to, create a shipping requirement for a customer. So tightly coupled, really low security model. Scaling is a big issue. Portability is a problem. And it's against best practices in CI/CD. We want to deliver features as fast as possible to our clients, to our customers. By using this technology, by using this model, we're basically making every single change a major disaster. It can be a potential disaster in our web application. So how do we avoid these problems? So the problem will be solved using a technology like containers, right? We use containers. In this example, we're going to use Docker, and Docker basically helps us put our code plus all the dependencies, right, in one place using the operating system. We basically close the container, we seal it, we make sure it's all good. We create something called image, right? We know that image is really consistent among the programmers, among the team. Everybody is using the same version that we're about to deploy. Then we send this image to basically a code pipeline, right? As soon as developers commit, we have a code repo that automatically it's going to build, let's say, for example, Spring Boot deployable file, WAR file, right? And then that file is going to go through a pipeline, and the pipeline is going to save this image into a image repository. So we use Amazon AWS ECR to save our images. So imagine you have three teams they're working on different features of the application. One of them, they're just working on a technology using Spring Boot and maybe some MySQL database, and they're working on a location finder for retail, let's say, application, right? Let's say we have retail locations, and this module, this service basically is in charge of finding those locations. They're adding features on a daily basis. Team A doesn't need to wait for Team B. They can just go ahead and commit their code and update their own image, which is their own container, right? And DevOps team is the team that's actually helping developers to deliver the code faster than ever to production, right? This is a DevOps operation, development operation team, right? So the goal here is to create the image plus code plus dependency and put everything in one place. So developer team A, right, if they're working on Spring Boot application, all of them, they're going to use the same image, right? So the code is going to work on every single machine, right? Developers are not going to argue, oh, I have this library, you use Python 2.7, I'm using Spring Boot version this. So everything is going to be consistent. Team B is going to use Docker to create their own image for their Python application using Ubuntu, and they're handling a payment code base, right? They're dealing with everything related to payment. So any change to payment module, it's going to only affect the small piece of application. So every single change to the payment module is going to be delivered using this pipeline. So they're going to create a Docker image. They're going to put the code plus image plus everything plus OS plus dependency in an image, and they're going to deliver that image to ECR. And the way this pipeline is going to work, this is what we're going to build. We're going to build this first section using Spring Boot. We're going to build a location finder, very simple Spring Boot app. And then we're going to wrap that in a Docker image, and then all the dependencies, everything. And then we're going to create a code pipeline that delivers the code from our machine to code repository and then to Amazon ECR. Amazon ECR is basically, it's a Elastic Container Registry where we save all these images into this ECR, into this repo. So imagine a library that you create all these different images for your application, and then you just put it in the library. And when you need it, you can just pull the image and start using it in your production environment. Well, this is a great architecture in terms of scaling, security, and all the good things that we talked about in the previous section, the previous diagram. The only challenge here is, what if I have 500 services? What if I have a lot of customers? How do I manage? How do I know how many nodes, how many images are running at the same time? What if one of them fail? How do I know? So the answer to that is we need a mechanism to kind of orchestrate, right? Orchestrate the coordination, the basically challenges that we face in terms of container management, right? So there are different technologies for a container orchestration. One of them is Amazon AWS ECS, which works really well with an Amazon ecosystem, because you can simply use other services in AWS and integrate your ECS with all of those services. However, Amazon offers Kubernetes, because Kubernetes is very famous technology for orchestration. I will be recording a Kubernetes in Docker, and I will show you guys how to use Kubernetes. It's an amazing technology. We're going to, in this example, in this tutorial, we're going to use Amazon ECS, which is a container service. In Amazon ECS, we will be building a cluster where we actually will be able to manage our containers, because under the hood, the cluster is going to run a bunch of EC2s, right? Now, those EC2s can be managed by Amazon, which they call it Fargate, or can be managed by you. Fargate just makes the process much easier, because then you don't have to deal with the underlying EC2 fleet of EC2 in order to run your containers, but you have the option. Well, we're going to build application load balancer based on the traffic that we receive. We're going to use auto scaling to scale our containers. So the way it's going to work, we're going to create a service. So the main rectangle that you guys see here is going to be our service. So we put auto scaling and load balancing in front of our service because we might want to run I don't know, three containers, 3 nodes at the same time for a service, or we might want to do different things. So we bundle those things in a service and we make the service really scalable, right? And then inside the service, we create tasks which we define. We say, hey, use this type of container for this, for this purpose, for this service. Once we have the container defined and we integrate auto scaling group and application load balancer, then we'll watch, we can receive the traffic and send it to a right container, because containers work based on a port that they expose. So for example, this container exposes port 8081, 8082, 8083, so we can redirect traffic based on target group to the right container. If someone is trying to make a payment, we'll just forward them to the right container. If someone is trying to look up for a product in our e-commerce website, we'll just forward them to that specific container. So you will see exactly how we're going to manage all these pieces together. I hope you have a good understanding about what Docker is, why we use Docker, and what we're about to build in this tutorial. All right, guys, we're going to build a microservice for our locations, right? This microservice is going to return a list of our locations for our retail business. Go to Spring, start the spring.io, use Maven build for your project. We're going to use Java. We're going to name our company Z Company. It's a fictitious name, and our service called location. So we're going to use web to build Spring MVC web, including REST API. We're going to use DevTools. We're just going to keep it very, very simple. We're going to go ahead and download this code. We're going to extract it and import to Spring Tool Suite. We're going to extract it first, and then we're going to import it into our Spring Tool Suite. All right, now we're going to go ahead and import this project using existing Maven project. All right, our application is ready. As you can see, now we have an entry point is location application.java. This is basically the entry point of our application. In order to make sure this application works properly before adding any feature, I'm going to just run this as Spring Boot application. This is going to automatically start Tomcat, which is embedded in Spring Boot, and it makes building microservices very fast for me, so I can test my application. As you can see, Tomcat already started on port 8080. You can go to your web browser, type in localhost colon 8080, but I'm going to use a tool called Postman in order to test my application. So what we're going to do, we're going to actually build a another Java class here, and I'm going to name this main controller. The right way of doing this, you should be creating a different package, put it in a different package. But in order to make this a simple tutorial, I'm just going to go ahead and put this in the same package. And I'm going to annotate this with REST controller. So the application knows this is going to be a REST controller, and then we're going to containerize this application. All right, we're going to import that. I'm just going to go ahead and create a get mapping. And get mapping is going to just map everything. Whoever is requesting our locations, this is going to be path, and I'm going to use a method in order to handle this incoming request. So I'm going to use return in string and call these get locations, right? And then what I'm going to just do here, I'm going to return locations, right? Perfect. So we're going to just rerun this application once more to make sure it's going to restart. We're just going to import all the annotations that Java needs. We're going to restart the application, and we're going to wait for Tomcat to become available. Once this is available, then we can just go ahead and test our application. Perfect. We're going to send a GET request to localhost 8080/locations, and we're going to send the request. Hopefully we're going to receive a request that says locations. Perfect. So our service is working. Now what we're going to do, we're going to just create a small class called locations, and we're going to return a list of locations for our end user. Let's do that. So again, you should create a different package for this purpose, but in order to keep this simple, I'm just going to go ahead and create it here. I'm going to name this location, and in this Java class, I'm going to create a few things, right? The first thing is going to be private string location name, private string location address, private double lat, and length, right? Perfect. We created those. And you guys know when we create a class, we need to create constructor, and we need to basically provide setters and getters. So we're going to go ahead and do that. We're going to right click and go to, first of all, to getters and setters. We're going to select all of them. We're going to hit OK. These are all the setters and getters, so we can basically set up all the variables. And then what I'm going to do, I'm just going to go ahead and create a constructor here. So a constructor using field. So I'm going to say, okay, perfect. One more thing at the end, of course, when we create this, best practice is to just create a toString method, which is a human, basically readable version of our toString method. I'm going to save this. So we created a class called location. Now what we're going to do, we're going to go ahead and create a bunch of location, right? Here it's going to be location. I'm going to name it location 1, and I'm going to name this location 2 and location 3. This is going to be new location, and constructor will be called new location, and it's going to be location name. I'm going to name this location 900. A location address is going to be 123 Main Street, and lat and lang is going to be, I don't know, 32.01, and then minus 128, 112, right? These are just fake numbers. I'm just making this up to make this work. So we're gonna change these to basically different numbers. Like say no location 920, location 800, just the location number. I can add actually location 700. These are my locations. All right, guys, I created 3 locations using my Java class. Now I'm going to create a basically list of locations that I can return to a customer, right? So first of all, what I need to do, I need to tell this method that you are going to return a list of location, right? Which we just built. And in here, we're going to go ahead and create a list of location. I'm going to name this retail locations, and this is going to be equal to new array list, and there it is. Now that I have this, let's import all the things that Java needs. We're going to import java.util, and in here we're going to import java.util. So now what we're going to do, we're going to go retail locations. We're going to add all these to the list. We're going to say add the location 1, right? And we're going to say add location number 2 and add location number 3. We're going to hit save, and at the end, we're not returning string anymore. We're going to go ahead and return retail locations. Perfect. So this should actually return a list of our locations. Tomcat just restarted automatically because of including dev tools in this Maven project. On port 8080, I'm going to go back to Postman. I'm hoping that when I hit this, I should be getting a JSON response from a server that shows my locations. Perfect. So this is our application, right? This application is going to return the list of our locations to the end user. We might want to scale this application if for some reason we become really famous, people just keep hitting our application. So this is the microservice that we are going to Dockerize, basically, or use containers to run. And of course, we're going to use the same Docker image to deploy this to ECS. So the first thing we need to do before we start building a Docker process is to install Docker. I want you guys to Google install Docker on Windows, on Linux, or Mac, whatever operating system you're using, and go ahead and install Docker. All right, guys, now I'm ready to create a container for this microservice. I'm going to go to pom.xml file and change the version to 1 just to make it easier. I need to make sure that I do have the right plugin, in order to build this this Maven file. So let's make sure that we have that in place. So I don't have that. I'm just going to go ahead and manually add that plugin. You can just follow the basically JDK path on your machine. This is my path. I'm going to save this. We're going to go back to the location. I'm going to right click and say nvn clean install. And hopefully this is going to use that plugin and to create this deployable file for this microservice. The build is successful. As you can see, the file location -1.jar is ready. Now we're going to go ahead and create a Docker file and hopefully test our Docker container. All right, guys, now I'm going to create a Docker file for my Spring Boot application. What I'm going to do, I'm going to open the folder inside Visual Studio Code, and I'm going to right click on the location and say new, and I'm going to name this Docker file. And I'm going to paste the recipe here. So basically, I'm telling Docker to go ahead and find this image, pull this down, copy the file that I have inside the target folder. If you recall, inside the target folder, I do have the jar file that is ready to be deployed, and copy this to the user app. Change the directory, working directory, to user app. Just touch the file to update the timestamp, and then of course the entry point, which is the running point of our application. Basically run this jar file so the container will start running our Spring Boot application. So what is going to happen now, I am ready to go ahead and get a bash here and say docker build -t location. I'm going to name this container location. All right, we're going to save this. I haven't saved this location. So it's going to download the Docker image, the standard one. It's going to create my customized version, and I'm ready to go ahead and run the Docker. So I'm going to say docker run -port 8080 : it's going to be 8080. This is going to be the container site. So the first part is my Docker host, and the second part is the container. So my container, I know it's running on port 8080. We tested on Spring Boot application. If you guys recall, our container, our Java Spring Boot application is running on 8080. Run the Docker application. There it is. Now, as you can see, as soon as I started my Docker container, the application started working. So now if I go ahead and issue command against port 8080, so this is going to basically return the application. Now, in order to make sure we're running on the right application, I'm going to change the port to 8090. So basically, if I hit 8090 on my local application, it's going to port forward all the requests to 8080 on my Docker container. So we're going to hit on 8090. There it is. So we just hit the Docker container and we got the result there. I'm going to also show you a bunch of Docker commands that might be handy when we're working with Docker. So if you do docker -- help, you will see a bunch of commands that we're going to use in this video. And it's just good to know that, for example, if you want to build a Docker container, you learned you can use Docker build, Docker CP, you can copy it, Docker commit, you can commit the changes. You can, for example, get the list of running Docker containers using Docker PS. We're going to use that. You can use Docker pull to basically pull the image from repository. RM, for example, you can remove container. RMI removes the Docker image, and a bunch of other useful commands here. So we're going to go ahead and use Docker PS, and as you can see, this gives you a complete list of running basically containers on your machine. If you don't have any container running, we're going to go ahead and do Docker images. So I have 2 images. I'm going to go ahead and start one of these containers. For example, let's say we're going to start this Amazon ECS image ID, and I have the image ID. There it is. I'm just going to go ahead and copy this guy and paste it here. And if I hit enter, it's going to start our Spring Boot application. As you guys know, this is how we start the container. And now if I go ahead and run Docker PS, as you see, we have 1 running container. We started it 13 seconds ago, and it's up this way. So, and Docker, gives automatically a name, a friendly name to this container. So if I want to now stop this container, I just need to go ahead and say, hey, I want to stop this container. And in order to do that, you don't have to actually type the entire thing. I can just do stop CDC6. So the first 4 digits, for example, it will just find it. As long as it's unique, it's going to stop it. And then if I now go ahead and do Docker PS, as you can see, there's no running Docker at this time. So I can go ahead and what I can do, if I do Docker PS-A, you will see it will give me a more basically a complete list of all the Docker containers that I started on my machine, and for whatever reason I stopped them, or they're running or not. So Docker PS-A will give you a complete list of the history basically. And I want to go ahead and basically remove all these Docker containers from my machine. I can do Docker RM. All I need to do, if you remember, we're going to do CD 60. We're going to remove the first one. We're going to remove the second one. It's going to be 857. We're going to remove the other one. It's going to be 643, and F68. Perfect. Now again, if we do Docker PS-A, there's one more we have to remove, Docker RM, and it's going to be 64. Now Docker PS, as you can see, it's returning nothing, and also the history is completely gone because I removed all the containers from my machine called Docker RM using that command. Now, if I go back to Docker images, as you can see, we still have 2 images. I want to go ahead and remove those images. So let's take a look at them. So I can do, instead of RM, this time I can do RMI, remove image. And all I need is just the image ID. So the first one is going to be F978. Perfect, deleted. And the second one is going to be 3F. I'm going to delete that one too. So now if I do Docker images, as you can see, there's nothing. Docker PS, there's nothing. So these are very basic, simple commands that you can work with Docker. We're going to use a bunch of Docker commands, in this video. We're going to start by going to our Amazon Web Services account, and then go to the Elastic Container Registry, where we can actually publish our Docker images, and we can deliver the image to our production environment. I'm going to click on start, and I'm going to use retail locations address, and make sure the tag immutability is disabled, because we want to update our basically images using the same tag, which is the latest. And we're going to tell the basically cluster to always pull the latest tag. which is the updated image from our repository. So make sure this is disabled, so otherwise you won't be able to update your images. So we're going to click on create repository, and there it is. I'm going to just copy the URI. If I go to the images section, you'll see we haven't published any Docker images to our application. I'm going to go back to my application location, and I'm going to get a bash command here. So if you pay attention in this account, there is a place in your AWS ECR account that says view push commands. So, and here's the basically push commands. This is how we log into our ECR registry, and we can basically push the Docker image that we're going to build right now. So this is what we're going to do. We're going to click on this guy, and then we're going to paste this. This is how we're going to log in to our ECR. And then if you take a look, basically it says Docker build -t retail locations. We're going to build a Docker image using the Docker file we have in the folder. And then the next one is going to be, we're going to tag this to the latest, as you can see. And now we're going to go ahead and push this to our ECR repository. This is going to push the image to Docker repository. One thing that you have to pay attention when you create your Docker file, the Docker file should be something like this. So there's no extension. It's called Docker file. And remember, F is lowercase. And if you use, for example, uppercase or something else in the section that we're going to basically automate the delivery of our basically source code and build a Docker image using CodeBuild, you're going to get an error because CodeBuild is going to look for this file name. And you can use Visual Studio Code, which is very accurate to create a Docker file, or any other editor that you're comfortable with. So perfect. And as you can see, we are pushing all these images to ECR. Now, if I go back to my ECR after this process, I should be able to see an image in my ECR. So the point here is, as soon as I refresh this, now you're going to see there's nothing yet because still pushing the image to the ECR. There it is. Now we're done. If we go back, if I refresh this, so now you see we have a latest image tag, right? And immutability basically will allow us, which we kept it disabled, will allow us to update the same tag using the new source code and features that we add to our production. So this is an image URI, and as you can see, it's been tagged with latest and a few other digest and publish time and everything you're going to hear. So we don't like this process because every single time that developers or myself, we want to deploy code to our cluster, it's going to be a manual process. This is not good. We can make mistakes. We can publish the wrong code. So in order to avoid this and automate this process, we're going to go ahead and create a code pipeline. We're going to create a pipeline so we can deliver our code as fast as possible and keep it close to our cluster for deployment. So we're done for now with ECR. What we're going to do, we're going to go to Amazon CodeCommit. So in AWS CodeCommit, we're going to create a new repository, and I'm going to name this repository Retail Locations. Perfect. And I'm going to hit on Create. So I am using a federated account, which means I'm assuming a role in my development environment, and I'm using Northern California region. What you need to do here in order to basically push code from your computer to AWS CodeCommit, you need to go to IAM section. So just click on services and go to IAM, which is going to be a place like this, and then go to users, and my user is going to be dev. I'm going to click on it, and I'm going to go to security credentials. And as you can see, I do have an account just for CodeCommit. I'm going to delete that account because I do want to recreate it so you guys see exactly how I do that. So generate credential. This is going to be a one-time key. So make sure you take note and you have this username password because we need to set this up on our local machine. But please pay attention. Don't use my key values because I'm after this tutorial, after this recording, I'm going to remove these guys. These are not going to be valid. Just generate your key value, username, password, and use this on your computer. I have to warn you that if you have used AWS CodeCommit on your machine, Windows Credential Manager in Control Panel will keep a copy of your credential. So if you go ahead and clone that repository, you will most likely are going to get error if you're using a different account or different username and password. If you got an error while publishing your repository to AWS CodeCommit, just go ahead to Control Panel and remove that from Credential Manager. So now if we go back, we can just simply go ahead and clone this using HTTPS method. And we're going to go here. And what I'm going to do, I'm just going to go ahead and go to home. I'm going to say git clone. And when I say git clone, space, and this is going to basically clone this repository to my local computer. But what I do want to know, I want to clone this to basically a folder, a parent folder, and I'm going to create a retail locations app, for example. So now if I go back, there it is. So as I told you, since I don't have any credential in my credential manager, AWS CodeCommit is going to ask me for username and password. And since we created that in the I am section, we'll be able to just go ahead and paste these guys, and hopefully we'll be able to connect to our AWS CodeCommit. Perfect. And says it appears that you have cloned an empty repository. So if you guys remember, basically created a retail location app, and here's my git folder because I want to keep that separate from the source code that I'm basically working with. So what I'm going to do, I'm just going to go ahead, let me clean up the page. So if I do ls, get a list of things that I have in here. So I do need 3 things from this folder. So I'm going to copy, first of all, a folder called target to retail locations. So, and if you want to copy a folder, you always use -r with your cp command. So I copied that. And I'm going to copy another file called Docker file. And I'm going to go to, again, to retail locations. Perfect. I need that file. And I do need another file called build spec that we're going to use in our basically code build section. So perfect. And now if I go back and if I do ls, so you guys know my repository is the retail location site. And now if I get in there and do ls, I do have the target folder, which is a jar file from my Spring Boot deployment, right? And I do have a Docker file who knows to pull Java 8 file Alpine, right? The blueprint, and then add some stuff to it from the target folder to build my Spring Boot microservice. And basically build spec YAML file. It's just going to be a file that has all the instruction for AWS CodeBuild to tell AWS CodeBuild what to do and how to deploy this image after building to ECR, to Amazon Container Registry, right? So let me just run cat build spec quickly and walk you guys quickly through what we have in this file. In this file, as you can see, I do have few phases. The first one is installation of Docker version 18, which we're going to use. So in AWS CodeBuild, we're going to use version 2. You're going to see shortly. And in the pre-build section, I do have few commands. First of all, I'm just echoing few, outputs. What's important here, if you guys recall, when I wanted to log into ECR, I used this command to manually connect to my ECR. This is just the automatic way of doing it. And as you can see, I do have a repository URL that I need to update here because this is probably from past and I need to go back and update this. You guys need to update this URI to your own address. And the rest, as you can see, is just going to say Docker build after the initial phase. The next one is build and the post build. So we have three phases here. So we're just going to go ahead and create a Docker image and we're going to tag it with the latest. And at the end, of course, we're going to push this to the ECR repository. These are the exact steps that I took when I worked manually to publish my Docker image from my local machine to ECR. Now, we're going to basically automate this process. So as soon as I commit all the changes to AWS CodeCommit, I'm hoping this will go to AWS CodeCommit and automatically starts the build basically project, and build project will be able to deploy this to ECR. All right, so what I need to do here, let's just make sure for a quick second that we have the right repository address. So this is going to be my repository. Here's the repository. We're just going to go back and make sure in the folder that we are working with retail, we have the right address. All right, I'm just going to paste this and make sure it's saved. And pay attention, this is going to look for Docker file in your directory. So we're going to close this guy. Everything looks good so far. So now, as you can see in my command line, I'm in a master branch of my AWS CodeCommit. So if I go back to AWS CodeCommit, where I have the repository, there's no commit basically here because I haven't pushed anything to the repository. So let's do that. If I do ls, I do have 3 files. So I'm going to clear the screen, and I'm going to go ahead and issue 3 commands in order to push any code to AWS CodeCommit or GitHub. So it's going to be the same, add everything, and I'm going to say commit that, and I'm going to just put a comment called initial commit. That's git commit, and I'm going to say git push upstream origin master. I'm going to push that to master branch of my AWS CodeCommit repository. This is the code repository where we track all the changes to our source code. We can monitor what changed, what happened. It's a great tool for software development, right? Exactly like GitHub, but it's just well integrated with Amazon Web Services ecosystem. So let's minimize that. And now if I refresh my AWS CodeCommit, that I just committed my code to AWS CodeCommit, and here's the build, and here's the author, and everything. All right, so this looks perfect up to here. Now I have a repository that inside this repository, I can basically see what I have. If I go to the code, you will see I have 3 files, as I mentioned: Docker file, a build stick, which has all the basically instruction for AWS CodeBuild and all the things that we did manually. This is going to be just fully automated this time. So let's go back, and now we're going to work with AWS CodeBuild. In AWS CodeBuild, we're going to basically automate the building the Docker image for a process. So if I create uncreate project, I'm going to name this retail locations, and we're going to go down. I'm going to go ahead and select AWS CodeCommit as a source code. This is going to be retail locations, and my branch is master. And as you can see, automatically pulls the latest basically commit that I made to my repository. I'm going to use manage images, but operating system is going to be Linux since I'm building a Java application standard. And I mentioned we are using version 2, and here's version 2. This is great. I need to check this box. Make sure to check this because we are building a Docker image, right? So now take a look. This is service automatically. CodeBuild is going to create a role for me. I need to copy this role because I'm going to tell you why. We need to give our CodeBuild access to work with ECR. When basically we build it, we need to publish this to ECR, to the container repository. Since we have a build spec and we haven't changed the file, so we don't need to specify anything here, no artifacts, and of course we're going to have retail locations for our CloudWatch that we can take a look at the log. So I'm going to create on a build. It says this is already exists, so let's change the name to 1 and create, because I was testing the same concept here. So when I create the build project, then I can in the meantime go ahead and take care of that rule. So in that rule that we talked about, remember the rule that I made using CodeBuild, here's a trusted entity. It's this guy. And if I click on that, you will see I do have 2 policies attached to it, which is related to code build. And what I'm going to do, I'm going to go ahead and do Amazon EC2 container registry power user. So this is the policy you want to associate with your role. Amazon EC2 container registry power user. I'm going to click on attach. And this is perfect. Now I have the policy attached to the role, so that will give my code build enough permission to publish anything to ECR. Now that I have a basically code build, I can go ahead and test that. We're going to click on start, and I'm going to wait because we are going to see what's going to happen. So now code build is going to take a look at my repository, which I mentioned I'm using AWS CodeCommit, and it's going to take a look at this build spec file, and it's going to do a bunch of things. It's going to build the image. It's going to publish it, hopefully at the end to the ECR. And if I actually go back to the phase details, you see now it's going through all the steps here. It's provisioning, and then it's going to say download source. And of course, we're going to wait for the logs that we can take a look at the entire logs as soon as it's ready. There it is. So as you can see, I have basically running Docker and then running AWS commands, logging into ECR, and then getting the basically tagging the image. And then at the end, as you can see, now we're pulling the image, and then it's going to be at the end pushing all these guys to ECR. And there it is. It says succeeded. And then if I go on top, you see it says succeeded. So now this means if I go back to ECR and refresh my repository, there it is. I do have a basically automatic image. It says latest. This is how we tagged it, because we always want to tag this with latest. So our operation knows that always we need to look for the latest and greatest image in our repository. So this is it. You just automated basically the entire process of pushing the image from your code build to ECR. We did that first manually. Now it's the automated basically way. As soon as you commit your code to AWS repository, it should start the build process and hopefully push it to ECR. So now we're ready to just go ahead and create a pipeline. I'm going to go to create pipeline. This is going to be basically the entire pipeline from code commit to deployment. It's going to be automated. So as soon as you commit a change, it's going to automatically start the pipeline and create the container and send it to ECR. So I'm going to name this retail location. That's going to be new service role. We don't need to modify this. This has everything for the service. And our service provider, source provider is going to be AWS CodeCommit. You guys know it's going to be retail location, and the branch is going to be master. We're going to let the CloudWatch events be active. And for the build, we're going to use AWS CodeBuild. You guys know we just tested our retail location one and it worked. And we're going to go next. We're going to just skip this, that we can just go ahead and deploy to ECS or Beanstalk or any platform you want. For now, we're just going to go ahead and skip this, and we're going to create the pipeline. As soon as I create the pipeline, since this is the first time, it's just going to go ahead and build the pipeline once, and hopefully we will see a good result, and we'll go to ECR and verify that. So as you can see, it says AWS CodeCommit is our source, and it says just now, and it should automatically start. There you go. It's just starting, and now it's going to go through the entire pipeline and build it and send it to ECR. There it is. So did the first step. It says initial commit. And then it's going to go to the second stage, which is going to be the build process. All right, guys, as you can see now, our pipeline is completed. If I go back to ECR and refresh once more, we should see a new image coming through using the pipeline. So this is the beauty of creating a pipeline. As soon as I go ahead and change something in my code and commit that to the repository, it's going to automatically start the pipeline and deliver my container to Amazon ECR, which is container registry. And then from there, it can automatically go to ECS cluster and run our microservice. So now we're ready to go ahead and start our cluster using Amazon ECS service. All right, guys, now we have the image ready, which is our container. And now we need a cluster, basically a group of computer where we can deploy our containers to. So if I click on create cluster, you will have basically three choices. The first one is Amazon AWS Fargate. Basically, Amazon takes care of all the underlying resources in order to run your cluster, which is a great way of building microservices. We're going to go ahead actually with this choice, but before we do that, you have the ability to create your own cluster using EC2 Linux or Windows, plus having control over networking. So in the first one, basically Amazon is going to take care of the EC2. So I'm going to create the EC2 Linux. I'm going to click on next. I'm going to name this ECS-test, and we're going to use on demand, which is pay as you go, no commitment. Spot will basically give you just discount, and you basically bid against the market, but you get a great discount. So I'm going to just go ahead and create something maybe small. Let's say like T2 micro, it's fine. And we're going to use just one instance here. You need to number of instances that you launch to launch into your cluster. Basically you have to kind of estimate your capacity. So the benefit of Fargate here will be AWS basically will manage this for you. You don't have to be worried about it. But if you are managing your own cluster, you need to kind of identify how much traffic you're going to receive. We're going to talk about load balancing, but this is basically kind of like estimate around capacity that you are going to need to run your containers. You can even pick your Amazon Linux AMI, and keeper is basically to log into your cluster. If you want to access your basically containers, you are going to need a SSH key. In this scenario, we're not going to do that. In the networking section, we can select your VPC, or you can actually create a new one. We're going to just go ahead with the default. We're going to have two subnets, subnet 0 and subnet 1, and we're going to create a new security group, and then all the traffic is going to be back and forth around port 80. Since we're going to use load balancer, this is probably the best scenario for us so far. So container instance role is building, and we want to definitely enable a container inside, which is going to create CloudWatch log, so we can take a look. So I'm going to click on create cluster. It's going to actually launch a CloudFormation stack, and this CloudFormation stack is going to launch the resources and create the VPC so we can deploy our container. I'm going to pause the video here, and we can pick it up as soon as it's done. All right, guys, as you can see, we have an instance type of T2 micro. We have one desired instance. We have one VPC and two subnets in it. And as you can see, we have a route table, and basically CloudFormation created everything for us. If I click on view cluster, now we have an actual cluster that we can create a service and basically start running our containers. And the status is active, and you can see we have 0 instances running at the time. So this was just to see how you can create and manage your basically cluster using EC2. So you have control over EC2 instances, and you will see some CPU utilization if you actually use this, because you do have access to, again, EC2 instances that's basically creating this cluster. So we're not going to use this one because I'm going to show you how to use Fargate. It's an advanced concept as well. So I'm going to go ahead and just click on delete me. All right, guys, now that we deleted our cluster with EC2, we're going to go ahead and create a new cluster using Fargate, which is the first option. You're going to click on next. We're going to name it ECS-Fargate. I'm going to click on create new VPC. We're going to set the default, and we're going to enable container inside, which is a CloudWatch log. So a CloudFormation stack will be started, and will provision the ECS cluster that we need for our microservices. So I'm going to pause the video, and we'll start as soon as the cluster is ready. All right, guys, now that we have the cluster ready, we need to create a task definition, because inside the cluster, if you take a look, if I click on cluster, you're going to see we have a service that eventually we're going to use in order to make this basically a service available. Underneath, we can run actually load balancing and auto scaling group, but every single service is basically it contains a bunch of tests that we're going to run on microservices. But in order to test our system before actually building a resilient service, we need to start making a task and basically test our system. In order to make a task a real container that's running in our cluster, we need to have a blueprint, which is called task definition. It's basically a JSON file that contains all the configuration that we need in order to launch our new task. So I'm going to click on new task. And inside the task definition, again, we get two options: EC2, which is basically we can manage the container environment ourselves, or we can just rely on Amazon and let Fargate manage the underlying infrastructure. I'm going to set that. I'm going to go next. This is going to be a retail locations task definition, basically. So task role, if your task definition is going to use or create or launch other AWS services, you need to basically use the task role. However, task execution role is basically allows ECS to go ahead and pull the image from ECR. So these are two different concepts. This is actually an exam question. It might be in Solutions Architect Professional exam. So if you go down now, we need to create a task size. Let's say, for example, I pick 1 gig and 1 CPU, they don't match. So I can use, for example, a container that uses 1 gigabyte and basically 0.5 virtual CPU. Now that I have execution resources, I can just go ahead and create my container. If you recall, we basically deployed our images for our container using CodePipeline. I'm just going to go ahead and grab the most recent one. I'm going to say we're going to use always the latest. So even if you build a new one or service gets rebooted and you launch a new, let's say, cluster, it's always launch a new task, it's always going to pick the latest tag. So this is going to be a container retail locations container. Perfect. And there's no private authentication since I have access to ECR. I'm not going to put any memory limit. This is basically going to terminate the container if it attempts to exceed this amount. Port mapping. You guys remember that we ran our container in Spring Boot on port 8080. So we need to basically map the container port 8080 to our cluster so we can access the content of this container. So if you scroll down, you can set up health check, you can set up environment, timeouts, network settings. You can do a lot in this section. Storage and login. If you're basically sharing volumes between your containers, you can basically mount one mounting point and then have all the containers talk to the specific point. So if the container gets killed, your application still can persist data. So I'm going to go ahead and click on add. There it is. I have one container and I have the memory usage here. I'm going to go ahead and scroll down. I'm going to skip these guys and just click on create. Now if I click on task definition, basically I do have a JSON file, which is a blueprint for launching a new task. Now we're going to go back to our cluster. One thing about cluster, you see it says no data CPU utilization, no data for memory utilization, which makes sense because we are using Fargate and AWS is managing the underlying EC2 resources. So click on ECS Fargate. Now before actually building the service, I just need to test my task and run one task to make sure it's working. So I'm going to create on run task. It says you need to change your launch time. I'm saying sure. I'm going to go ahead and click the Fargate model. So let's select all these guys and number of tasks is 1. We're going to scroll down and we have to select the UPC here and both subnets. We're going to assign a public IP so we can access our container. So let's create, and as you can see, it says provisioning. Now it says pending. Now it says running. So if I click on my task, you see we have a cluster section, and inside the cluster we have a network which has a private IP which we don't want to deal with. This is all the instances that they're going to use this basically IP subnet in order to launch new instances. We don't want that, but there's a public IP address. We were configuring our microservice to use port mapping 8080. Well, the problem is very easy here. If you take a look, we are using an ENI here. An ENI, it has always a security group attached to it. So that's how exactly security groups work. You assign a security group to ENI, to network interface, to allow or reject. So basically to allow a traffic. So let's say if I click on this security group, you are allowing port 8080, but you're trying, basically, if you're trying to access port 8080 on our microservice, and that's not going to happen. And the reason is we are not allowing port 8080 to basically move forward. What I'm going to do, I'm just going to go ahead and use 8080. There it is. I added 8080. Now I'm going to directly access my microservice on port 8080 and go to the /locations, which is on my get mapping. So port 8080, now directly we are accessing our microservice directly, basically from outside. We're using this public IP address, and our microservice, we know it's running on port 8080, so we need to open up port 8080 in our security. Again, this is just for testing purpose. We're going to go ahead and remove that when we create port 80, because we're going to create a load balancer that hits port 80, and then from there it automatically maps it to 8080. But for now, in order to access to our container, we need to open up that port. So I'm going to go back to my ECS cluster, and what I'm going to do, I'm going to create another task. There it is. Again, I'm going to create another task. And we're going to go ahead and select the VPC, and there it is. I'm going to select the same thing, and I'm going to assign a public IP. I'm going to run the task, and we're going to actually provision another one because we just got more users. But this is kind of silly because someone needs to sit here and basically spin up servers, take a look at the traffic. This is not going to work in real life applications. So we need to actually build a service that service can have multiple tasks and automatically can provision based on load balancing and auto scaling. So our system can basically respond to the demand. So, but for testing purposes, we're just trying to see if we can access our container. But in the next step, what I'm going to do, I'm going to actually build a service, and we're going to create a reliable, resilient service. But for now, let's take a look at the second service, and let's see if it's running. So the second one has a different public IP address. And if you take a look, this was the first one. Now we're microservices. There it is. Now if I hit the basically service, you have two microservices with different public IP addresses that can serve the same content to users. So now if 100% of the users are hitting this endpoint, now you can actually send half of those users to another one, so you can offload from the one server. So you can scale. But this scaling methodology, it's not right. And we know why, because we are basically doing everything manually. So what we're going to do, we're going to go ahead in the next section, we're going to pause these guys, right? And we're going to go ahead and create an actual service so we can make a resilient basically microservice. All right guys, now that we stopped this basically task, we can go back to the service center, and in the service center we can go ahead and create a service. Let's just try creating a service. We're going to call it retail location, and we're going to use the same cluster service name, and replica. As you can see, it says replica services place and maintain a desired number of tasks. So how many do we want? I want to have, for example, 3 tasks running for me, and the minimum healthy percentage and the maximum healthy percentage, we're going to keep the limit as default, and we're going to use a rolling update. You can do blue-green deployment, which is basically you create a test environment and production, you test the code, and when it's ready, you basically send all the traffic to the most recent version. We're going to just do rolling update, which is just a fashion, and you basically just go ahead. If you have 3 let's say a task, you just start by updating the first one and then second one, and so you do it gradually, not all in time at the same time. And we're going to create on next. Sorry, service name. We're going to name it retail service, and we're going to go next. There it is. So in the next section, we're going to actually set up our VPC. We're going to say use both subnets that we have here, assign a public IP, and we're just going to go ahead. For now, we're not going to use a load balancer. In the next step, we're going to use actually application load balancer and send the traffic to a target group. So we're going to move forward with all the basically settings that we have here, and for now we're just going to use an area record. Go to the next. And for auto scaling, again, we're not going to use it right now, but I'm going to show you how to set this up, all of them, auto scaling group and load balancing. So as you guys can see, the service now is created. We're waiting for the final step. It says 2 out of 4 completed. I'll pause the video and we'll pick it up as soon as it's ready. All right, guys, now it says 5 out of 5 completed. Everything is ready. We're going to go and take a look at the service. So take a look. As soon as I created the service, my service went ahead and started 3 basically microservices. As you can see, they are all running and they're in healthy, because I mentioned I need desired count. Take a look on the top of the screen. I say desired count is 3 and it says pending 3. You have all 3 instances are running, and as you can see, they were provisioning. Now they're activating. These are the basically steps that our microservices are going through in order to become basically active. If I go back to the details, as you can see, our service now is basically running 3 different tasks, and tasks are running, and they have their own public IP address. So we're running 3 instances that basically they are serving the same application. So one more thing before actually we finish this section. So now since we created the service and the service is active, as you guys can see, we're going to actually put a load balancer, and you're going to use the DNS record of our load balancer to send the traffic. But the point that I'm trying to make here is as soon as we said the service, it needs to run 3 instances, it automatically went ahead and started 3 instances. If I go ahead and change the desired number to, I don't know, to, for example, 1, and if I go to the next step and next and next and next, if I update the service, if I go back to my tasks, you're going to see that the service automatically removed 2 of the instances out of 3, because I mentioned the desire will be 3. And that's why basically the service is the way to go and the way we create resiliency for our task. Now, if I go ahead and update this to 5, the system is going to automatically scale. But we're going to do all these things automatically using auto scaling group and load balancing and finish this tutorial. So let's set that up. Now we're going to actually build an application load balancer, because if you guys recall, when we designed the Spring Boot basically service, microservice, we named it / for example, locations, right? So we know that we can route users to different pages and to different part of our application using URL. So when you want to basically use HTTPS in order to specify the traffic and send users to different part of your application, this is where you use application load balancer, right? This is a layer 7. If you take a look at the OSI model, a layer 7 is basically your program has the understanding capability to work with layer 7, which is HTTP layer. So what we need to do here, we need to go to load balancer section, and I'm going to select application load balancer, and then we're going to create a target group that basically puts bunch of machines under one name, basically groups them by IP or instance ID, so we can redirect the traffic to those instances. So I'm going to click on load balancer. I'm going to use application load balancer. As you can see, this is layer 7 load balancer, which you can work with HTTP and HTTPS. I'm going to click on create. I'm going to name this ECS application load balancer. And what I'm going to choose, we're going to choose internet facing, because this is going to be the entry point of our application, and it will be port 80. Since it's on HTTP, you can definitely do HTTPS and offload it, do like SSL termination at your application load balancer layer. For now, we're going to keep it IP4, and then it's going to be for port 80, which we're basically listening to receive the traffic on port 80. So I'm going to click on next. In the next section, before I click next, we need to make sure that we can launch applications, we can launch instances, we can redirect, basically load balance between two different availability zones. Basically, this is how we load balance between two different basically resource set. We're going to click on next. We're going to move on for the security. We're not concerned at this time. Basically, what we need to do is to make sure port 80 is basically open. And what I'm going to do, I'm just going to create this load balancer security group, and we're going to name it basically ALB port 80, for example. And then we're going to go next. In the next section, we're going to create a new target group, and our target group is basically going to be our path, and we're going to just name this default. So every default traffic for now, because we are going to create different route you're going to see shortly, but for now we're going to select default, and we're going to pick IP. Basically, we're going to group everything based on IP. If you guys recall, when I showed you guys how to create a basically task in your cluster, we had two microservices running here using two different IPs. So we're going to tell our load balancer that use the same technology to route traffic between the microservices, and we're going to use port 80 and HTTP, and we have a health check. So health check, this is going to check on the ELB level. So you always want to make sure you have a health check within your microservices. So for example, let's say your load balancer is healthy and it says, oh yeah, I'm available, and it returns basically success code of 200. But unfortunately, for some reason, your application crashed, so user cannot communicate with your work with your application. So you always want to make sure basically you can set up application health check within your microservice. So for now, we're going to go for targets. We don't have the targets yet. We're just going to go ahead and go to the review, and we're going to click on create. We're going to work with the targets you're going to see shortly. So I created a basically application load balancer, and it says provisioning. And what is happening, basically, you always with load balancer, you're going to get a DNS name, right? You're not going to get an IP address. This is actually an exam question, an associate level for solutions architect exam. And you will see everywhere in different AWS exams that they try to basically give you options that has an IP, but you always get a DNS name. You can map this DNS name to Route 53 and actually redirect traffic from www.yourwebsite.com to this DNS. So basically all the users will be directed to your load balancer, and from load balancer, the traffic will be distributed to different availability zones in order to load balance the traffic. So this is perfect, and as you can see, we have an IP4. We are using two availability zones which we can distribute the traffic between the two. We have a security group that I named it ALB 80, which allows port 80 to be open. And one thing I want to show you guys here, if I go back to the listener, since we were using application load balancer, right, we can redirect the traffic based on the HTTP requests and traffic. So it says if you receive traffic on port 80 by default, go to this place. If you recall, I actually set this up, but I want to change this now. So I want to go to this edit, And what I want to do, I want to say edit this guy, I want to remove this, and I want to say everything when comes here, just return a 50310 and say hello, I am here, right? So we're just going to return this response as a default basically value. Now if I go back and grab my DNS record and go back to my web browser, you guys are going to see that I'm getting a response from the ELB that says hello, I'm here, and I'm hitting, remember again, DNS which is a record for the application load balancer. So I can basically map my website.com to the load balancer, and I can scale the service in case I get million users. The system application load balancer is going to automatically scale the system. So for now, we don't have much to talk about here. As you can see, this is like still says provisioning. Now it says active, and we were able to route traffic to it. Now what we're going to do, we're going to use this application load balancer in our ECS cluster where we run our microservices, and we're going to create a load basically auto scaling group that can scale our microservices automatically behind a service. So remember, we always want to create service, not a simple task. We will basically build a service that uses multiple tasks, multiple containers underneath to make sure we are highly available for any incoming request. All right, guys, now that we have application load balancer, we can create a service. A service basically make sure that you have enough tasks in order to serve your traffic. If you become popular and famous and people want to visit your website and get your retail location addresses, you can scale out and scale in based on auto scaling policy that we're about to set up. So let's get started. We go to create service. We're going to use Fargate as underlying technology. As you know, Amazon Web Services is going to manage that. Task definition, there's a task definition, and we're going to use our cluster, and we're going to name service name. This is going to be a retail locations service. Perfect. And this is going to be Fargate. Number of tasks, we're going to start with 1, and we're going to use rolling update. We're going to go next. We're going to select our VPC, and we're going to use 2 subnets to launch our instances. So we need to basically use the port 80 policy that we defined. This is by default is going to create one, but if you guys recall, I created one called ALB 80, which does the same thing, basically opens up port 80 in order to serve traffic to open internet. We're going to go down, we're going to use application load balancer. As soon as I activated selected application load balancer, Amazon Web Services is giving me a health check grace period, and I'm going to say, hey, give me 60 seconds to make sure the instances, they have enough time to register as healthy. Otherwise, we're just going to keep launching instances without waiting for them to register and become healthy. So you may need to find this right number for your application, but I'm going to go with 60 since we don't have much going on in our application layer at this time. But for real life applications, you definitely want to check the time that requires an instance to basically give an instance enough time to register as a healthy instance. Application load balancer, this is our application load balancer, and a container that we have, we know it's called retail locations on port 8080. I'm going to add this to load balancer, and I'm going to say, hey, on port 80, I know my basically production listener port. This is going to be the listener that on load balancer, we're going to listen to port 80, but we're going to redirect traffic to 8080 to our container. So I'm going to create a target group, right? We can create a new target group, and I can name this, let's say SRV, just a new target group. And it's going to use HTTP based on IP, as I mentioned. And the pattern is going to be slash. I'm going to send everything to slash, right? Or we can create, I have an existing one that I set it up just right now, and you can set up everything to send basically all traffic with evaluation order, which basically evaluates the order of the path. But I'm going to match everything to basically to be redirected to my container. So we're going to go ahead. We're not going to change anything on the Route 53 side. Here's the part that we can set up auto scaling policy. If we receive a lot of traffic, we're going to start with 1. We're going to say that's the minimum number that we're going to have 1 instance if someone wants to check. Our desired is 3. We kind of know roughly this is our traffic pattern, or if we don't know, we can start with something and to find out and expand our plan. And the maximum with 5 instances for retail location. Hopefully we should be fine and serve our application properly to our end users. So here's the important part. We are going to set up a policy for our scaling. So we're going to scale out and scale in. We say you can scale out. Basically, this is going to be scale dash out when CPU utilization is over 10% for more than 1 minute, right? And when this happens, please add 1 task to basically when it's over 10 and less than infinity, right? And we're going to do the same thing actually here, scale in policy. This is going to be another alarm. We're going to say this one was scale out. Sorry, I misspelled this to out or hour. I'm going to be changing to out. Save. And the other one is going to be scale in. So if we don't have visitor and the average traffic is less than or equal than 10, the other one was basically less than, let's say it's less than 10 for 1 minute. Now what we're going to do, we're going to go ahead and remove 1. So see, it's smart and it knows you, it gives you basically remove option now. When it's less than CPU utilization is less than 10 and less than minus infinity. That sounds good. We're going to go to next, and we are ready now to launch our service. Let's go ahead and do that. Beautiful. As you can see, everything went through. Now the system is creating all the resources to run our service. We should basically see our instances running. It says 9 out of 9 completed. If I go back to my view service, now you guys see it says pending. It's basically going to the pending. If we had lifecycle hook, see, this is basically now in the pending. We could basically stop the pending and do more like installation if we wanted to do different things. But the point here is you have now 3 that they're in activating mode, and our service, remember, we always want to work with service, and behind the service we do have 3 microservices that are serving our retail application. So the way we want to test this, once they're all running, see where the first microservice was on, the second microservice is on. Now here we have 3 running microservices for our retail location. It says desired is 3 and running is 3. So what we're going to do, we're going to go back and we're going to actually go ahead and test our application. And remember, the way we want to test our application is through load balancer. That's what we did, right? We copied this address and we said we could basically redirect traffic from our website.com to our microservices. One thing we need to basically make sure it's running here. If I go back and take a look at this section, so see, now we have all instances, 3 instances that all running, and it says they're unhealthy, right? So there's a problem that all the basically instances they are running, and it says they're all unhealthy. And the reason is we're looking at port 8080 here, right? And if I go back, all right guys, why our applications are basically registering as unhealthy? So if you go back to the security group that I created, I added port basically 80 for ALB. That's the only port that ALB knows to communicate over. So what I need to do, I need to let the ELB know that there is a port called 8080, and I can actually reference that security group of ALB so I can allow any traffic from load balancer from this security group on port 8080. So if I go back and now refresh the application, hopefully I should get the result. And remember, you can always in security groups, you can address another security group. So when I use this SG number, whatever you guys see here, I'm telling AWS that the security group on my ELB is only allowed to pass the security to pass the traffic on port 8080 if it's receiving from the source. Basically, this is basically securing your application load balancer traffic to your microservices. And there it is. Now, as you can see, we're hitting the /locations endpoint on our application load balancer. There it is. Now we're running our containers using Docker and Amazon ECS. One last thing before we basically finish this project, and now you can see we scaled in. I'm going to go back for the last time. Imagine, since our application is not actually scaling out and in, I can do that manually. So let's go that and do that once more. And I want to again say I have 1 and the desired number is 3. I'm going to go next, and this is going to happen based on the traffic. Basically, you can receive more traffic through your website. So now you can see the desired is on 3. If I go to task, now the service is automatically provisioning 2 more microservices for me, and they're going to be available shortly and register with the target group to receive traffic. And there it is. My application is healthy, and as you can see, I'm hitting the endpoint, and we're getting the address of our locations. We became popular, and ECS automatically now is scaling out based on CPU utilization, and it is going to basically put them on the desired capacity. Since our traffic is not that big now, and we're not receiving much traffic, as you can see, ELB automatically auto scaling group automatically basically scaling in. At the end, guys, I have to let you guys know that you have to delete all the resources that you guys created, to avoid any charges to your account. So make sure you go ahead and deregister and put all the desired value to 0, and remove auto scaling, remove your load balancer. Make sure in the cluster section, there it is, I have nothing, no task definition, and no cluster. Also remove my load balancer, so the account is empty. I'm going to go ahead, since if I'm done with this, I can just go ahead and simply delete this image as well. So I have no repository, and the cluster is also empty.
Alright guys, I hope you enjoyed it. Don't forget to like this video. If you haven't subscribed to my channel, please subscribe. I hope to see you guys soon. Bye.